Good evening, everyone. Welcome to tonight's session. Okay, so in this session, we're going to be looking at the second part of flowchart. In the previous session, which was our first session on flowchart, we were looking at how to convert a flowchart to a pseudocode to flowchart. In this session, we'll be doing the opposite. We're going to be converting a flowchart to a pseudocode. Okay, so but before we get to the conversion, I want you to take note of something very important. And this is something called indentation. So to indent simply means to write some text, like you leave some space in front, like the way we leave margins when we're, what example can I give? Like for example, when you're in English, when you're writing letters, there's a way you indent, you leave some space when you are plugging in those paragraphs. Let's say for example, what example can I give? Like after the reference, you don't start writing right next to the margin. You go inwards a bit and then you start writing like that. And then the next line will be right next to the margin. I'm sure you remember how we used to write those paragraphs like that in English. So this is the same as what we are seeing on the screen here. You notice to say the word start. Okay, let me use a different one. That's yes, this one. Notice to say start is starting from here. Just draw it properly. Imagine this is our margin. Okay, let's draw a line. Call it our margin. Let me just draw a straight one. Why is it not adjusting? Okay, this thing is misbehaving. So imagine this is our margin. Okay, you notice to say start is starting from there, and then the next line there's this space that has been left there. Okay, this space right there. So this is what we call indenting. Again, the next one, there's some space that has been left there. So you notice to say enter and print are also in the same line. You notice this is in the same line like that, and then all these lines of code are also in the same line. So you notice how we are leaving spaces here. There's some space left there, there's some space that has been left, and then it's the same as everything else up to this guy here, end if, and then print is in the same line as enter. So this is how you write code. You don't put everything in the same line, where start, enter, or also, let's say enter is also starting from here in the same line with start. That is not how you write code. So you are required to indent. Okay, that is something that is very important. You can notice even with the other questions, if you come to this one, you notice start and stop, same line. Okay, they are in the same line. I don't know why this thing is misbehaving. Okay, you notice they are somewhat in the same line and it's misbehaving again. Okay, let me try again. Okay, you notice those are in the same line. Enter and display, same line, and then the rest are also in the same line. So these spaces that we're leaving here, okay, this space that has been left there, this whole space that has been left there, and then there's this space that has been left there, this is what we call indenting. So this is how we write code. So at secondary level, indentation is not that strict. You notice to say start and stop in this case are on the same line, while enter and display probability are in the same line, and then everything else, these guys are all starting from the same line. You notice here they're starting from the same line for this particular code. If you check another code, let's say this one, you notice to say start and enter, here they're in the same line. Print and stop, they're in the same line, as opposed to the previous one where this one was going to be moved inwards. Same applies with this guy here. So this is why I'm saying they are not that strict. But if you go to university level, those that are doing programming and everything, like Mr. Emmanuel there, you understand to say indentation is very strict at that level. So what you can just master is this. Something very simple is this. Okay, you can simply adopt this principle where start and stop should be in the same line. they should start from the same line, like that. Okay, and then enter, and the last display just before stop, there's that display or print. Okay, these should also be in the same line. The first enter. So what does that tell you? Like in the previous examples, like the assignment I gave you, there were a couple of formulas and inputs you are making. You had to enter slant height, you had to enter something else also. So meaning if you have another enter, it should be in the same line as this enter right there. Okay, and then everything else, the if, the else, the display, the end if, all these should be in the same line. So you can simply adopt this simple format where you make sure that start and stop are in the same line, enter, and the last display. Okay, you notice there's also display here. Okay, so the last display where you're displaying whatever it is you've been calculating, they should both be in the same line. And that is basically that about indentation. Okay, so now in this session we're going to be converting flowchart to pseudocode. So we already understand what we are doing in the previous session, and so in this session it's going to be very simple. All we have to do is simply copy the information we're seeing on the screen, but the only different thing or the only distinct thing is indentation. That's all, because here we simply have to write start. Once you write start, what is next? You say enter RHR. Okay, once you enter RHR, there is this guy here. Okay, you are converting is from is. What is if? Okay, originally we had if, then we converted it to is. You remember in the previous session we said you have to phrase it as a question. So meaning in this case, since we are doing the opposite, is will now change to if. If, so meaning it's going to be if R is greater than capital letter R, then you're going to put the word then, and then you come to this guy, print error, R is not valid. Okay, when you're going towards the no, what were you write? What was written in the code? There was else. Okay, else, and then you have the formula there. After the formula, there's this guy, print, and then stop, and you're done. Okay, that's pretty much what we're going to be doing. The only thing I need you to take note of is that here you convert the is to if. You convert it back to if. Once you convert it to if, and then you copy what is inside here, but you remove the question mark, you need to add then. Okay, you add then, and then you come to this message. You write it down just the way it is appearing. Okay, then towards the no, you have to put the word else. Okay, else, and then you write your formula. Once you write your formula, remember right before print or display, the last guy, there was a word we were skipping. There was a sentence we were skipping. Which one is that? And if. Two words we were skipping. So just before you write this, you need to write and if. Okay, then you write stop, and you are done. So let us now try to convert this flowchart to pseudocode. Okay, so the first part we are saying start. So we say start. Okay, then you indent inwards, you leave some space. Okay, the next line will start from somewhere here. Just leave some space. And then we're going to say enter. So I say enter. What are we entering? Just copy what is inside this shape. Okay, enter RHR. Remember, this is case sensitive, so you plug in the values according to their respective case. Okay, so we are done with this one. What is next? There's is here. Okay, we are on that decision box. We said is needs to be changed to what? To if. So again, you have to indent inwards. So you say if what? R is greater than R. So I'm going to say R is greater than R. I said when you are moving towards the yes, you have to put the word what? Then. Okay, so I'm going to say then. What do I do next? I come to the error message. So the error message, I'll also indent it inwards. If you want, you can put it right there. There's no harm. You can say print, open double quotes, error, comma, error. You're just copying. Is not valid. And then you close. Okay, and then we're going now towards the no. I said when you're going towards the no here, there is a special word. Which one? Else. So you have to write else right here in the same line as print again. Else what? You display the formula. You simply copy the formula, not display. Copy that formula there. So we're just going to say V is equal to what? Open bracket, pi asterisk, that is times there, times H, close bracket, and then that is /3, okay, another asterisk, okay, then you have open bracket r to the power 2. So power is written using a triangle like this, that is facing up. So r to the power 2 will be written like this. Some of you on your calculators, you don't have that option where you have to like manually plug in the power. You say 2 to the power, then the 3 will appear there, meaning you have to say 2 and then you press that button that has this symbol, and then you do this. So this 2 to the power 3 on your calculator will appear like this. I'm sure some of you have already noticed that, since we are looking at probability, geometric progression, and we're dealing with a lot of powers which you needed to be punching in manually. So this simply means r to the power 2. Okay, so r, then you put that triangle there to the power 2. What next? We have plus here, we're there, plus r to the power 2 again. So plus small letter r this time around, the power 2, okay, then plus r asterisk, okay, times r. Let me just push it to the left. Where is that guy? Okay, this one. Push it to the left so that you can finish the formula. So r asterisk for multiplication. So just copy everything the way it's appearing. Don't make a mistake. Times r. Okay, then the bracket closes. Let me shift back to the left. Okay. Just give me a moment. This thing is misbehaving. Okay, let me use this again. Nice. Okay. Taskbar is disturbing me. Okay, great, we have it. Okay, I think that's enough. Okay, so we are done with that line of code. This one. We come to the second last line. So we said before the second last line, there is that special guy, the one we were omitting last time, end if. Okay, so we need to write end if here. End if again in the same line. End if, then we said enter right there, should be in the same line as the second last line of code. So meaning I'll put my print right there. Print v. Okay, they are in the same line. These guys here, they are in the same line, like that. Just as everything else here should be in the same line, like so. So now remember again, we said start and stop should also be in the same line. So meaning my stop should be in the same line as the start up there. So I'll simply put my stop right there, and you are done. You have your 5 marks. Okay, so far, do we have any questions? If there's a question, you can raise your hand, then I'll give you an audience, or you can post in the chat. Okay, otherwise that is how you indent. So remember we say just make sure start and stop same line. Okay, like you can see here, start and stop are in the same line. Then this guy here and the last guy, I think this is the simplest way as far as a graphical representation is concerned. You can simply master it this way: start and stop same line. Okay, the first shape and the last shape, the second shape, the second rectangle. Okay, let me use their respective names, these two. Okay, the first parallelogram and the last parallelogram, they should also be in the same line. then everything else in between should also be in the same line inwards. Okay, I think that is the easiest way you can remember this. So we can now proceed to the second example, since we don't have any questions. Okay, so same thing again here. The first oval, start and stop, same line. The first parallelogram and the last parallelogram should be in the same line. Everything else in between these guys should all be in the same line as well. So we simply copy what we're seeing here. Okay, so we're going to start like that, and then we indent, we leave some space here. Okay, we go to the next line. What does it say? Enter R and 0. So we go inwards, and then we say enter small letter R, comma 0. No punctuation. Don't put a comma there. Remember I said last time that code is quite sensitive. You add a comma where there's not supposed to be a comma, the code won't run. So here just copy everything there they are appearing. Don't put what is not supposed to be put. Okay, and then we said the next, so we have done this guy and that guy. We are coming to this guy here. What did we say about is? You need to indent it inwards also, but you convert it to if. Remember in the previous session we were changing it to is. So now we take it back to if. And then what do we do after you do that? You copy what is here. Okay, is if R is less than 0, but you don't put a question mark this time around. If R is less than 0, okay, the first thing you're going towards what? The yes. When you're going towards the yes, there's a special word here again. Then you write it there. Okay, then what next? You go to the next line where you get to print the error message. So again, in the same line as if. I just want to simplify things. I don't want to end the print, to indent the print. I'll just put it in the same line. Okay, print, open double quote, error, comma, R is not valid. Just copy everything the way it's appearing. You close with a double quote. What next? You're going towards the no. Okay, there's also a special word here. What is a special word? Else. Okay, so again in the same line with print you put else. Okay, well after you put else, what should you do? So if you want, you can actually write the formula right below else. You can put it here. A is equal to, open bracket, theta, but for the sake of mastering this, I'll stick to one method so that it can stick. So I'll put the formula just there. A is equal to, open bracket, theta over 360. Remember I said the forward slash means division. Over 360, close, times. Okay, the asterisk there. Pi, you remember this formula, area of a sector, eh? Pi times radius. Okay, radius is squared, so there's that triangle there. Okay, allow me to call it a triangle. I know it's not a triangle, but allow me to call it a triangle, or maybe an arrow or something. Okay, so that is your formula for finding the area of a sector. Okay, then what is next? There is this print. This is the second last parallelogram. We said before the last parallelogram there is a special word we are omitting last time, and if. So you need to plug it in there. And if. Okay, and then you go to the last print. So we said the first parallelogram and the last parallelogram should be in the same line. So meaning the next one should also be in the same line as the enter there. So I'll put my print right here. Print, what are we printing? We're printing A. And then start and stop. Remember I said it should be in the same line. So I go outwards in the same line as start up there. Okay, I put my stop. And that is our pseudocode. We have successfully converted this flowchart to a pseudocode. Do we have any questions? Is it making sense? Is it making sense? Please give me a thumbs up. By now, things should start making sense. Okay, I can see some thumbs ups. Okay, I don't know if that's the right way to say it, but yeah, I'm getting some feedback. So now let me make a comment on this one. There's this guy here, this arrow. Okay, it doesn't really mean that you need to write something pertaining to this arrow you're seeing here that is coming up to this point. All it's saying is that when you follow, if for example, this is basically what the program is doing. You start the program, right? It's running. Then you enter your values. You enter the radius, you enter the theta. Okay, and then it checks, is the radius less than 0? If it is yes, meaning it will print you, it will show you an error message. Okay, let's say for example it says syntax error. Okay, I think there's a Y here. Syntax error on your calculator if you enter wrong values. Once it says syntax error, what happens? The program terminates, it stops. That is why it is coming here and stopping. That is all this means. So there's nowhere on your code where you need to write anything pertaining to this arrow here. Okay, the only thing you need to write is usually included in the error message where it says re-enter. Okay, so here it will be included, something like that. It will be put somewhere there. So this arrow, it just tells you to say after it checks and it finds that the value of r is less than 0, the program terminates, it stops. That is all that arrow means. So don't bother yourself by saying, okay, what is that arrow, what am I supposed to write to show that there's an arrow here, something. Okay, so that is that. We proceed to the last example. Okay, now this one is a special one because it also has another question which is going to serve as a reminder to what we have already covered. Remember, we already covered this question the time we're looking at calculus paper 1. I hope we remember that, and I hope we have been revising. Okay, because we are approaching the month end. As you know, every month end we get to have a test. Okay, today is May 19th. So this month end we're going to have a test, and it will actually compose the entirety of section A. Our goal is to finish section A this very month. Then next month we just look at section B. So we look at section B and then we start revising. That is our goal. So I hope we have been revising. We should know how to solve this question. I actually wanted to bring it as an assignment, but I thought, okay, let me be nice to these people. Okay, so we'll start by evaluating this one. So what do we do when you have such a question? Okay, so we have, this is we have a 2 there, the upper limit and the lower limit, and then you have those brackets where you have 6x to the power 5 minus x to the power 4, and then you have plus 3x. So I'll ask a question quite soon. I need someone to be ready to answer. Okay, how you integrate a constant. So please prepare an answer. I'll just mention the name and then I'll need an answer from whoever I'll mention. Okay, so remember we said when you're solving such a question, you're going to use these types of brackets. When you're integrating, what do? You need to add a 1 to the power of x. So we say plus 1, and then what you have up there, 5 plus 1, that will be your denominator here again, just like that, 5 plus 1. Okay, I hope those that forgot are now remembering. Minus x to the power 4, we add the 1 to the power of x again, and that becomes our denominator again, 4 plus 1. Okay, plus we have 3x2 plus 1 over 2 plus 1. Now we get to the constant. What are we doing there? Let me check who's online so that I can see what I'm going to ask. Okay, how do you integrate a constant? Okay, let's see. Who do I have online? Let me just check everyone who is online. Messi, how do we integrate a constant? What is going to happen here? The -1. How are we going to integrate? We have already integrated the other terms, so we're now remaining with -1. How do we integrate that one? Okay, you can unmute your mic and tell us how we're going to do that. Just trying to check whether people have been revising or they have been forgetting what we have been covering. Okay. If she fails, I'll pick another person to pick it up. So please don't say that, don't be grateful that actually you picked somebody else. I might come to you next as the savior. Okay, how do you integrate a constant? Do people still remember or they have forgotten? Okay, to the rescue, allow me to choose. Let me welcome someone new. Limpo. How do you integrate a constant? Have you already covered this topic or you need a refresh? Okay, I said I'll be nice to people. Let me be nice. Okay, I can see a hand up. Francina, do you want to answer? If you want to answer, please unmute your mic and attempt.
So we introduce.
What do you introduce?
We introduced an X.
Okay, so introduce an X, correct? What X do we do? What do we do next? We then say,
and then we make it 0 plus 1 to the power 0 plus 1.
Exactly, over 0 plus 1. Okay, and then we close. There's no need for us to add a constant, remember, for this type of equation. Then you put your upper limit there and your lower limit there. Okay, nice one. I hope we now remember. We need to know how to differentiate a constant and how to integrate a constant. When you're differentiating a constant, let's say for example you have a 2 there, dy over dx. We said this guy just becomes a what? Becomes a 0. Okay? And then when you're integrating a constant, you need to add an x. Actually not this one. When you are integrating, when you're differentiating, let's say 2x. This one just becomes a 2. The x, we said, just simply disappears. How does it disappear? I explained. Okay, allow me not to go into that. That's not the business for today. Now, when you're integrating a constant, meaning this x needs to come back. Okay, so how does it come back? To sustain it, you need to add a power to it. Okay, remember it is coming with a power of 0. So when you add the 1, that's when it's now going to be 2x to the power of 1. Because any value raised to the power of 0 is what? Is going to be a 1. So meaning this will give you 2 times 1, giving you a 2. So this is basically how the x would disappear. How does it disappear? Okay, let me explain for people that are new. Okay, dy over dx. If you are integrating something like this, 2x. When you're integrating, what were we doing? We subtract a 1 to the power. Okay, so here the x is raised to the power of 1. When you subtract a 1, we're going to remain with 2x to the power 0. Okay, because 1 minus 1 gives us a 0. And then any value raised to the power of 0 is what? Is a 1. Okay, because 2 and x are multiplying, that's why we're multiplying here. So meaning what do you get at the end? We just get a 2. So the shortcut is, whenever you have a variable raised to the power of 1 and you're differentiating it, it simply disappears, and that's how we remain with a 2. Just as we have here, this is a long cut here. I was just showing you how it disappears. So now when you're integrating, the x needs to come back. So before it disappeared, it had what? A power of 0. This is a 0, it has right there. Okay, then when you add a 1, you are going to sustain it, and then it is going to be 2x raised to the power of 1. So whenever you're integrating a constant, you need to add an x, you raise it to the power of 0, and then since when you're integrating you add a 1, you add a 1 to it as well. Okay, I hope we now remember. These are questions we shouldn't fail in the exam. Okay, we're done with that commercial break. We can now proceed. So we continue simplifying. So inside the bracket we're going to have 6x to the power 6, because 5 plus 1 there will give us a 6, everything over 6. 5 plus 1 down here also gives us a 6. Okay, minus x to the power 5 over a 5 there. Okay, and then we're going to say plus 3x to the power 2 plus 1 there will give us a 3 over a 3 there. Okay, minus x. 0 plus 1 will give us a 1. Okay, so there's an invisible power there, which is a 1. Then you close, and then you plug in your upper limit and your lower limit. At this point, we can simplify. The 6 and the 6 will cancel. So what do we remain with? We're going to remain with x to the power 6. Okay. Then here we can't simplify anything, so we'll just leave it the way it is. X to the power 5 over the 5. If you want, you can put 1 over 5 x to the power 5, like that. And then we say plus the 3 here, and the 3 will cancel, so remain with x to the power 3, then minus x. We have successfully integrated. Okay, having integrated successfully, we're now going to get this integrated function. Wherever there's x, we plug in a 2 in the first bracket. So allow me to start it from here. So I'm going to say 2 to the power 6. Remember, wherever there's x, there's an x there, so I've put a 2. And then I've raised it to the power of 6. Okay, minus. Okay, so now for this one, how are we going to do it? Okay, we can simply put it like this. Where there's x there, there's what? There's supposed to be a 2. So I'm going to say 2 to the power of 5, and then everything over a 5, like that. Okay, then we say plus. Again, there is x cubed. So we're replacing x with 2. So we're going to put 2 cubed minus a 2 there. You close. That is the first bracket. You say minus. Open. You go to the second bracket. Now, wherever there's x, we're plugging in negative 1. So meaning we're going to say negative 1 to the power 6. For this first part here. Okay, we're using the same function. I'm sure you remember by now. Okay, minus, open bracket, negative 1, close bracket, raised to the power of 5, over a 5 there. Okay, and then plus, again, open bracket, negative 1, close bracket, to the power of 3. This part here. Okay, minus, open bracket, negative 1, close bracket. And then we close with a square bracket. So we simplify this part, we put our answer here, we bring down the minus, we simplify that part, we put our answer there. And then we finish off. Okay, so we can punch in starting with this bracket here. So if your calculator doesn't allow you to punch everything at once, you can simply punch them in chunks. You can say 2 to the power 6, find your answer. Let me just get my calculator. So there are those of you with advanced scientific calculators that are able to actually punch in the original question. Okay, this question up here. Which one? This one here. There are some calculators that are able to punch that, like mine. So that is what I would use to confirm. So we are now working on this first bracket, this one here. So we're saying 2 to the power 6. So that is 2. Let me put them in brackets. 2 to the power 6. So meaning some of you on your calculators are going to put 2. You press that button. This is 2 to the power 6. Okay. And then we say minus. This is a fraction. Okay. So that is 5 to the power, not 5, but 2 to the power 5. 2 to the power 5. Okay. Just erase something here. Over 5. And then plus 2 cubed. 2 raised to the power 3 minus 2. Then I close the brackets. Okay, I confirm what I've punched. 2 to the power 6 minus 2 to the power 5 over 5 plus 2 to the power 3 minus 2. I press equals. That gives me a fraction. Says 3 over 18. 318 over 5 over a 5. Okay, and then we bring down this minus there. Okay, minus. So when you find one term this side, that's when you can remove the brackets. You now come to the other bracket, this guy here. We punch everything there. Like I mentioned, if you're unable to punch everything, do it in steps. Negative 1, close bracket, raise to the power of 6. Okay. Then we have minus. There's a fraction there, negative 5. So let's put the negative 5 in brackets. Negative 5, close bracket, raise to the power of what? 5. Negative 1, not negative 5. Negative 1, close bracket, raise to the power of 5 over 5. Okay, I wish I could show you how my calculator is punching these. Okay, plus, open bracket, negative 1, close bracket, raise to the power of 3. Then, minus, open bracket, negative 1, close bracket, close bracket. I confirm what I've punched. Okay, so there's negative 1 raised to the power of 6 minus brackets negative 1 raised to the power of 5 over 5, and then plus negative 1 raised to the power of 3 minus negative 1. Okay, cool. I have 6 over 5. So this side is giving me 6 over 5. At this point, we can now simplify these two fractions. So we're going to say 3 over 15 over 5, 315 over 5, that's 315 or 318. Okay, I'll confirm in a moment. Minus 6 over 5. This gives me 309 over 5. I'm not sure whether I wrote the same value there. 309 over a 5 as our final answer. Let me just confirm this part. I'm not sure if I copied the right thing. So 2 to the power 6, 2 to the power 6 minus 2 to the power 5 over 5 minus 2 to the power 3 minus 2. Okay, close bracket. 2 to the power 6 minus 2 to the power 5 over 5 minus 2 to the power 3 plus, actually not minus, plus 2 to the power 3 minus 2. Yes, this gave me 318. I wrote 315. Okay, so meaning 315, this answer will change. Okay, so make sure you check through your work. Like you've noticed, I was saying something else and I ended up writing something else. Over 5. Okay, this now gives me 312 over a 5 as my final answer, and we are done. Okay, then I can confirm using my calculator by punching in everything. So I'll simply say open brackets, the original. What is the original? Which is 6x to the power 5, 6x to the power 5, and then minus x to the power 4 plus 3x squared minus 1, close bracket. I confirm what I've punched. The powers, we have 2 and negative 1, 6x to the power 5 minus x to the power 4 plus 3x squared minus 1. Okay, that gives me 312. Why chonga no kuichonga mu exam at nakariak. Okay, this should be 3 marks. Yeah. Okay, so we are done. That was a refresher. Okay, we now go to the business for the day. So remember we said, maybe before we proceed, is there anyone with a question, especially those that recently joined, those I didn't teach this subject, this topic to? Would you have any question from anybody? There's no question, we can now finish up. Okay, there seems to be no question. We come to this one now. We said start and stop, same line. First parallelogram, last parallelogram, same line. Everything else in between. Okay, that sounds weird though. Alright, so we start. Okay, start, we indent inwards, we say enter. This question looks repeated. Is it just me or it looks repeated? It actually is the same as the previous one, isn't it? Let's see. Looks exactly the same. Should be the same. Yeah, I think it's the same question. Okay, so we're pretty much done, but I need to do another question. Let's see if there's another one we can find from the other questions that we can convert, so that we have a last example. What do I have here? I don't have these guys. Okay. All right, let's have another example. Okay, let me plug in another question. Meanwhile, just give me a moment. Let me plug in another question so that we can have one last example. I feel that way will be content that we have covered enough. Okay, will there be any question as I'm looking for an additional question? This is the one I intended to. Let me check. Do I have this one? What are we calculating here? Okay, this is volume. So on the long formula. Okay. This one. Okay, yeah, found the question I intended to plug in. Just give me a moment. I can shift this to question. Example 3. Example 3. And then this guy. Bring in this guy. Okay, so this will be our last example. So just like we did for the previous questions, sorry about that, I thought I'd already plugged in the right questions, not knowing that I repeated one question. Okay, so start and stop, same line. Okay, the first parallelogram and the last parallelogram, same line. Everything else indented inwards. So I'm going to say start. Next one is this guy here. Enter SRN. So I've written that one. We're now on this one. So we indent inwards. We say enter. What are we entering? S, small letter R, then capital letter N. There's no punctuation there. Then we come to this rhombus, which is a decision box. There is there. What do we put? We say if. Okay, if what? We copy what is here. S is less than 0. S is less than 0. Okay, we proceed to the yes part. What did we say? We need to plug in there. We need to plug in then at this point. And then we go to the next line. We write that error message. In the same line with if. We say print, open double quotes, error. Okay, S must be positive. S must be positive. Close with the double quotes. You are done. We come to this part. Why there is no, I said there is a special word there again, which is else. Okay, you write your else, then you copy the formula there. D is equal to S times, remember I said the asterisk means multiplication, times R divided by 100, okay, times capital letter N. You are done. Okay, before the last parallelogram there's a special word there, a special phrase, which is what? And if. And then we said the first parallelogram and the last should be in the same line, so we now need to go back outwards, and then we put our display here. Display what? Display D. Okay, then we said start and stop should also be in the same line, so again we go back outwards and then we say stop, and we are done. We have our 5 marks. At this point, do we have any questions? We're pretty much done with session. Are there any questions? If it has made sense, you can respond with a thumbs up. If you have a question, you can raise your hand, then I'll give you an audience. Okay, I can see people are responding with thumbs ups. Is it thumbs up? Okay, great. All right, so we are done with flowcharts. We don't know what they'll bring in this exam, whether they'll ask you to convert a flowchart to pseudocode or pseudocode to flowchart. So you shouldn't be handicapped. What do I mean by handicapped? Where you only know how to convert pseudocode to flowchart, you don't know how to convert flowchart to pseudocode. In case they bring that one, you are gone. So make sure you know both, because you don't know what they're going to bring for you. Okay, this one is pretty simple, as you have noticed. You just need to take note of a few things. Okay, start and stop in the first line, like I have tried to simplify things. The first parallelogram and the last parallelogram in the same line. Everything else, you know, is supposed to be indented inwards, and there's nothing that is not given here except for else, then, and if. Those are the only words you need to add to the information that they have given you here. Otherwise, all you're doing is you're simply copying and pasting. Okay, so this is a very simple topic. Please, it is only going to be simple when you practice. Like I always say, mathematics is a practical subject. If you're not practicing, you're just watching videos, and then you go into the exam room, you will not remember everything you are watching. But when you are practicing, things are going to stick. Okay, you're going to start knowing what you are doing. So please practice, and practice. That's how you get better at mathematics. If you want to get a distinction, you need to make sure that you're applying yourself. Don't just watch videos and you end there. You need to practice. Otherwise, that is that. Thank you for making time for this session. I'll share the assignment in the exam, in the groups. As always, we're going to be dealing with exam questions. Yeah, so otherwise, that is that. Thank you for watching, and I'll see you in the next one.